Hi, welcome back. Thanks for tuning in. We're going to talk about renewables today. I had a request in the comments section. Could I talk about renewables? Been talking about gas processing and about refineries and about chemical manufacturing. So being a man of the people, this is going to be it. Wind turbines today. We'll maybe look at some other renewables as we get going down. I'm involved with hydrogen projects and solar and battery storage, that kind of thing. So we'll keep it all spicy, okay? So with that, what we want to talk about, what can take our wind turbines down? What is it that makes wind turbines fail? And why do risk engineers need to learn about wind turbines? They can break down from equipment failures, they can catch on fire, and then the environment itself can threaten the wind turbine. As you try to do your own research and learn about this, if you type in environmental threats about wind turbines, what you're going to get is the threats from the wind turbines to the environment. You have to be really specific saying in the way you ask your question about environmental threats to the wind turbines, like lightning or ice or environmental factors, not killing birds. Okay, so again, what makes it so different, a wind turbine or a wind farm versus a typical power plant or a gas processing plant? It's the sheer number of pieces of equipment. You know, you can have 100 wind turbines on a site, and maintaining 100 pieces of equipment climbing up and down these towers is a challenge. The workers that work in these facilities can only climb 2 to 3 towers a day before their body just can't do any more. Just going up and down 2 or 3 times is about the human body limit. So they look at devices like Climb Assist that basically it's a pulley and a weight system that makes it easier to climb, takes half your weight off of you to be able to climb up. So we're going to have folks inspecting these towers to make sure that they don't fail. That's part of risk management. We have to also be aware that the towers themselves are risks just to climb. Alrighty, now let's talk about breakdown. What is it that can fail in a wind turbine? A lot of moving parts, and the blades are going round. The blades are also pitching. So there's lots of movement that's occurring, and there's gearboxes. And the gearboxes in the early days, the wind turbines had to they were just being cranked out as quickly as possible, and there were manufacturing issues as well as design issues with stress risers in the gear teeth. So gearbox failure was common in the early part of the wind turbine industry. And HVAC failure. Remember, again, this wind turbine is up there on the top of that tower, and it's trying to make electricity out of the wind. Well, when it converts the wind to electricity, some of that energy is lost. About 70% of it is lost, and we end up with a lot of heat. We have to get rid of that heat. The HVAC system must work to get rid of that heat. As soon as the HVAC system stops, that's when the time clock starts for the failure, because you need the HVAC system working. We'll talk about weld porosity on the tower sections and a actual loss. It's not a John Muno video if you don't get a real loss story, and tell you what happened, how we discovered it, and how we resolved it. We'll talk about transformers. We made a complete video on transformers and how to manage the risk of transformers. But again, all power generation, is made at a voltage other than the grid transmission voltage. So there needs to be step-up transformers on site. And all the transformers that are at a wind turbine or wind farm, subject to the same failure mechanisms like the oil breaking down, overheating, overloading, the paper breaking down, same kind of things that we see. So dissolved gas analysis is your best friend, or partial discharge analysis is really your best friend. DGA is there, but go watch the video on transformers to understand why partial discharge is even better. And then vibration. We got moving parts. We got these things moving so much of the time that anything that can be affected by vibration is going to be a risk issue. So the bearings, the blades, the tower itself, just moving back and forth. So this is an idea of what the mechanical risks are. Now, let's delve into, or that's the way AI talks about it all the time, getting us to say, let's talk about the weld porosity and what happened. I'll get back out of the way. So the welds on the side of the tower, or around the tower, they're there to hold these tower sections together. And you have about 3 or 4 sections, so there's 4 or 5 welds. And what we saw, we had a fire at a wind turbine, and when we got there, what had happened was the HVAC filters had gotten clogged up. It was in Texas, so there was a lot of sand, a lot of dust. The filters clog up, the unit overheats, the electrical equipment starts to burn. The heat of that fire causes the hydraulic accumulator to fail. Then oil blows out throughout the inside of the nacelle and all down the inside of the tower. Okay, so how does oil get on the outside of the tower if it all ran down the inside? And if it's on the outside, why is it only at these welds? Well, that was several of the questions that we had was, and it was on the upwind side that we saw the oil leaking out. So it would kind of be the side that got bent more, that you can just imagine the tension on the side and then opening up a little bit and allowing that oil to flow out, if that's what was going on. So the forensic investigator that was assigned by the insurance company was not a power gen or an industrial type forensic investigator. I think they literally went to the yellow pages and pulled out forensic investigator. They got a crime scene investigator, and he had the little card fold over things with the numbers, and he had a map. He was drawing every piece of scrap metal that had fallen off that nacelle and everywhere it went. And he saw a dumpster where they were just picking everything up and throwing it in a dumpster. And he said, stop. He went over there and he had a pick and a brush, and he's combing through this dumpster. Didn't know what he was looking for, but he's just looking at everything, writing down exactly what everything is. Well, for an insurance claim, all we need to know is that it's a fire, that it was accidental, and nobody did it on purpose. We don't really need to get into the detail that he was getting into. He had $100,000 worth of forensic gear in the back of his minivan. And when we started talking about these oil spots on the side of the wind turbine tower, he got his little microscope out and he walked over and started looking at one of the welds. And he said, you can see the porosity yourself. And I looked at it, and it looked like Swiss cheese. It was like just a big sponge. So clearly, oil was coming out of these welds. And I thought that meant that water could go in through the welds on a rainy day. So the plant manager was a little concerned. He said, do I need to shut down this entire wind farm? And we said, well, the towers were here yesterday, they're here today. It's not like it's an overnight emergency, but we need to figure out if these welds are structurally sound. So they had a structural engineer come out, look at it, and basically give us his blessing that no, it wouldn't hold vapor or liquid, but yes, it will hold the tower up, and it is structurally sound. So, fire, okay? There are a lot of ways that we can have fires in the wind turbines, and they happen occasionally, and we see the pictures. Again, insulation can overheat, and that can just be because the HVAC system fails. The brakes can fail. A hydraulic oil accumulator is going to be your source of fuel that if that goes, you pretty much are going to kiss the nacelle goodbye, probably the tower too. But the electrical equipment that is in that buttoned up, bottled up nacelle, if you don't keep it cool, it will be the source of your fire. So let's prevent the fire from starting, and then we don't have to worry about how we're going to get it out because it's so high up there, so hard to get to. What do we do? How do we get to a fire? It's a couple hundred feet up off the ground. And we don't want to use our ladder trucks because we're worried about the tower falling into our ladder trucks. So we can talk about fire protection systems. The biggest issue with a fire protection system is that the cost, right? When you have 100 wind turbines on a site, and if you spend $50,000 per wind turbine to protect it, you've spent $5 million. You could have bought another entire wind turbine, blades, nacelle, tower sections, everything for the cost of what you just spent to put fire protection everywhere. So rather than spend all that money on fire protection, you could just buy a whole spare, and then in the next 20 years, whenever you have that fire that destroys one of your machines, you've got that spare to go in there and put it in, and you haven't spent any more money than you would have if you'd have bought 100 fire protection systems. And yet your risk is still managed to the same degree. Maybe even better, because the fire protection system does not stop a fire, it just puts it out after it starts. So there's no telling what kind of damage you're going to have to recover from, even if you have a fire protection system. But if you have a spare wind turbine, you don't have to worry about the damage because you've got a spare. Now, if you've got 100 wind turbines in your field and you've got one in the warehouse waiting for that fire, it could be making money, right? So over the next 20 years, instead of it sitting in the warehouse, why don't we put it in place? Why don't we install it? Why don't we use it? Now we've got a wind farm with 101 wind turbines, but we don't have any fire protection. Guess what? We don't need fire protection because it makes sense to put this thing in the warehouse and wait for the fire. It even makes sense to take it and put it back out in the field and let it run, because it can make power that whole time that could buy another wind turbine before you need one from a fire. So open it up. You guys that disagree with me, come on, tell me why we need fire protection and wind turbines way up in the sky. And I'd love to talk about it. I'd love to have a podcast and bring somebody on to have a little engineering discussion. Alrighty, that was fire protection. And again, they're spread out so far, and the potential for one unit to involve another is so small. I've never seen it happen. Okay, you can get multiple units damaged by a hurricane or a windstorm, but I haven't seen a wind turbine fire do it. Maybe a grass fire could do it, but not an actual wind turbine fire. So I don't see the point in fire protection. And I'm a fire protection engineer. All right, now the environment. And again, I'm not talking about hurting the birds and the low vibration sounds and all the things and the effects of the outside. At this point, we're talking about what can hurt the wind turbine, what in the environment can hurt the wind turbine. So lightning, right? You're going to hear a really interesting fact that I learned doing this research for lightning. Windstorms, sandstorms cause erosion over time. This can cause failure. So again, as risk engineers, we're involved with what's insured and we're involved with what's not insured, because they both involve risk. And in the matter of some of the exposures here, we can't get insurance coverage for them. It doesn't mean that we don't want to manage the risk. Flood risk, we can wash out the footers of these wind turbines if they're in a floodplain. And I've seen that where we've had collapses of wind turbines because of flood. Haven't had an earthquake collapse claim to work on, but I have to imagine that it happens. And then with ice and snow, that's an interesting one, because the ice can damage your equipment, but it can also hurt the public. If the ice accumulates on the blades and they're still spinning, it can slip off, right? And it can fly, and that chunk of ice can hit another wind turbine, the tower, and cause it to fail, or it can hit a blade and cause it to break. Or that piece of ice can be flung off-site. And when it flies off-site, there's a potential that it hits a person, an operator, a mechanic, somebody coming to work, somebody nearby. We actually had a project where there was a park near where they were going to build the wind turbine. And we did the modeling, the mechanical engineering of what happens if a blade breaks. Will it fly off-site? What if half a blade breaks? Will it be able to fly off-site? So we had to figure out, did we increase the risk of anybody in the park before we proceeded with the project? Lightning, that's out there. I'm just amazed at the information that I got. Seeing all these guys being hit at the same time kind of gives some meat to this one. But the average wind turbine gets hit 10 times per year from lightning. I couldn't believe it. They had one that measured 100 lightning strikes in 1 year. We all thought that one lightning strike was all it takes, and boom, it blows up and it's no good. No, they're pretty durable. These wind turbines withstand lots of lightning strikes before they do fail. But yet that is still one of the things that can cause them to fail. Some of the protection systems that we see in there are like target discs in the fiberglass blade that have wire that bonds all these discs that are there to attract the lightning strike and then hopefully take that current down to ground. Well, in order to get to ground, it's got to go through the bearings, which can cause pitting. So we have to be careful about inspecting our bearings and making sure that our bearing temperatures don't just mysteriously start to rise after a thunderstorm. So lightning can be a challenge, but just be aware that the industry has overcome the challenges pretty well. We talked about ice. That's another environmental factor that can cause problems. Now, when you're dealing with risk engineering, again, in all the fields, you need to know what the values are, because that's what risk, that's, frequency times value. That's what the risk is. So what are we trying to protect? Well, a wind turbine tower section, just a piece of that tower, and again, they have between, 3 to 4 or 5 of these sections, $300,000 to $350,000 per tower section. The nacelles themselves, again, depending on the megawatt output of the unit, somewhere between $2 and $10 million for a nacelle. A blade, one blade, $300,000. Now you need 3. Sometimes lightning hits 1 and the OEM says you got to replace all 3 because we can't match that a new blade to the 2 old blades because of the wear that they've seen, and the new blade is going to have a different performance. We have to replace them in sets. Of course, the insurance companies got very frustrated with that, and they said, how about we repair that one that broke and we will warranty it for the rest of the life of the machine. But then when they were faced with, what if that blade that you warranty breaks and flies off and hits somebody in the public or kills an operator? Are you going to accept the liability for injury, for personal injury versus property damage? We get that. You're going to buy us another blade if it breaks, but if it kills somebody, we want you to step up and pay for that. Oh, no. We're not going to do that. So back to the OEM version of you got to have all 3 blades. Or they went to the policies, and now policy wording can be very restrictive in order to get a set of blades. Gearboxes. $250,000. And again, this is something that the insurance industry managed with wording. We'll talk about serial loss clause in a minute. Crane rental can be outrageous. And the thing about a crane, it could be $25,000, $50,000 a day to rent it. But when it shows up to site, it's not put together. It's not ready to use. It comes in pieces, right? So it takes about 4 days to put this crane together. And oh, by the way, you need another crane to do that. So it's not just a matter of it comes in and you start using it. So it's a big process. And then you get your crane built after almost a week, and the wind's too high for you to approach the nacelle. You have to back away. You wait 2 or 3 days. Finally, you get up there, you pull the nacelle. You have to be able to pull the top tower section on the same day you pull the nacelle, because you can't leave a tower without a nacelle up overnight. It's not structurally stable. Believe it or not, it needs a compressive force of that nacelle. We ran into that. We were trying to pull a nacelle because the wind backed us out in the day, and then we ended up having to wait till the next day because we needed time to get that top tower section off as well. So crane rental can just be outrageous on wind farms. How'd the insurance world respond to all this? Well, they came up with serial loss clause. And the way that works, again, for my chemical manufacturing engineers and all you fire protection guys out there, this is insurance stuff. This is geeky stuff. But basically what the insurance company said was, you've got 100 of these machines, and when the first one breaks, that might be an accident. But when it happens again, and it's the exact same part, that's going to raise a flag. And we want you to figure out why that's happening, why it happened twice on the same piece, same part. And if it happens 3 times, that's when we're going to start shaving back coverage, because clearly there's not enough going on at step 2 to make it not happen anymore. And, we might give you 75% coverage for the 3rd one. And then the 4th one, maybe 50% coverage, and maybe the 5th one, and everyone after that, no coverage. So that's how a serial loss clause works. And you have to be careful when you build a project that's got this cookie cutter approach that, serial loss exclusions can impact your risk management. The definition of damage is huge. So be careful about what is called damage, like testing costs. And some policies are called damage, and that's fine. The cost that it takes to determine the scope of the damage is fine. The cost that it takes to determine that the repair was done correctly is fine. Not all policies are like that. Okay, so this is where you need your broker, and you need to make sure that you're getting the most coverage you can in the market with your loss history. Then defect exclusions, the whole concept of, something breaking over and over again is a defect, right? And that's the things that the insurance company want to distance themselves from. They want to be there for the unforeseen, fortuitous, but they don't want to be there for the maintenance and we need to fix this. It's just something that should be in the budget. So you'll see very tight defect exclusions start to pop up in cookie cutter type risks. So that's wind turbine risk engineering. It's quick. It's in a nutshell. It's not from a expert who walks out into wind turbines every single day. I've been into plenty of wind farms, met with the manufacturers. I've been in the industry long enough. But this was mainly for all you guys that are trying to learn the general concepts of energy risk engineering. You may be in a power plant that doesn't have wind. You may be in a chemical manufacturing plant that doesn't have power generation. So that's my goal, is to basically help everybody who wants to learn to be risk engineers. Keep the comments coming. I love doing this. Thank you.